Dear friends, let us begin with the topic sets. Sets. I'm sure you are familiar with the definition of set. You might have studied in lower classes. So set is set. Set means well-defined collection of objects. Well-defined. It is well-defined collection of objects. It's a well-defined collection of objects. Here the keywords used are well-defined and collection. We can add one more word here of distinct objects. Distinct means objects have to be different also. So well-defined collection of distinct objects. Distinct objects. See, I take natural numbers from 1 to 5. 1, 2, 3, 4 and 5. All these 5 numbers are different. If I pick up any number, let us say 5, I can state that this number belongs to this collection. I can think of some other number, let us say 7, and I can say that 7 does not belong to this collection. So by the phrase well-defined, by the phrase well-defined, we mean we should be able to say with certainty for the given element whether it belongs to a given collection or not. Then secondly, these all are different also. So we can say that this collection of natural numbers from 1 to 5 is a set, and we always denote sets by capital letters. Let us use S for writing this set. 1, 2, 3, 4 and 5. So these 1, 2, 3, 4 and 5s, these will be called elements of set. These will be called elements of set. Elements of set. And this S is for name of set. I'm using a book by Mr. Gautam Kumar. Name of this set. Book is by Gautam Kumar. By Gautam Kumar. So similarly, we can write some other examples of set. Let's write second example. Set of natural numbers less than 2. Less than 2. Set of natural numbers less than 2. It means we are able to write only one number, that is 1 only, because minimum natural number is 2. Sorry, minimum natural number is 1. Minimum natural number is 1. So this set contains only one element. You can write it by using capital S as a symbol for notation. So there could be many examples. Set of all prime numbers. Set of prime numbers. Set of prime numbers less than 10. So this set will be, so minimum prime number is 2, then 3, then 5, then 7. 8, 9 and 10 are composite numbers and 10 is not included here. This becomes set A. It contains 4 elements. It contains 4 elements. More examples we can write, like set of natural numbers. Set of natural numbers. One, two, three, dot, dot, dot. These 3 dots indicate that it is endless. The same pattern continues. Same pattern continues. Set of integers, -3, -2, -1, 0, 1, 2, onwards. It is also infinite set. It does not stop anywhere. The counting does not stop anywhere. So we take some now examples from the book. Say, which of the following are sets justify your answer? The collection of all the days in a week beginning with S. So the days will be Saturday and Sunday. So this is set. These days are well defined. So therefore, this is set. Answer is yes. This is set. Second is collection of 10 talented actors of India. Talented actor. Talented actors. Now here the word talent is not well defined. I may call somebody to be talented. The same person may not be talented in the eyes of others. So therefore, the set of 10 talented persons, actors of India, will not be set. So not a set. That will not be a set. That will not be set. Next is the collection of 5 great batsmen of cricket. Great batsman. Great batsman. Great batsman. Now, how to decide if somebody is great batsman or not? It is not possible to decide. With the same logic, I may consider somebody to be great batsman, but he may not be the same in the eyes of others. So this is also not a set. This is also not a set. This is also not a set. Then the collection of all girls in your class. Set of all girls in your class. This is set. Set of all girls in your class. Yes, it is set. It is set. The collection of all even natural numbers less than 9. Set of all even natural numbers less than 9. These will be 2, 4, 6 and 8. So this is set. It contains 4 elements. It contains 4 elements. So I told you, for a collection to be a set, all elements should be different and each element should be well defined. By looking at the element, we should be able to state clearly whether it belongs to collection or not. There should not be any element of uncertainty. So now, how to describe a set? 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 There are mainly two ways of presenting a set. There are mainly two ways of presenting a set. One is called roster form, roster form. Other is called set builder form. Other is called set builder form. In a roster form, we write elements of set actually. In roster form, hope you're understanding. In roster form, we write elements of set actually. Separate them by using commas and enclose them in curly brackets. For example, if I write set of prime numbers less than 12, so these will be 2, 3, 5, 7 and 11. So I have written all the elements satisfying the condition being prime number less than 12, prime number less than 12. So I have written all elements. These are 2, 3, 5, 7 and 11. Separated them by putting commas. Now I enclose them in curly brackets. This set A is a set of all prime numbers less than 12. The way we have presented it, this form is called roster form. This form is called roster form. This form is called roster form. So there could be countless examples of writing sets in roster form. Like, let us say set A showing squares of natural numbers less than 5, less than 5. So square of 1, 1, square of 2, 4, square of 3, 9, square of 4, 16. So these all are squares of natural numbers less than 5. Which are less than 5? That is square of 1, 2, 3 and 4. So this form is also called a roster form because we have written all elements, separated them by putting commas and enclose them in curly brackets. So when we write elements actually in curly brackets, it will be called a roster form. The other name of this form is a tabular form. Other name of this form is tabular form. So we can call it to be roster form or a tabular form. It has same meaning. We can take few more examples for this form. Set of all natural numbers which divide 21. Set of all natural numbers which divide which divide 21. So 21 has factors 1, 3, 7 and 21 itself. Therefore, the corresponding set will be 1, 3, 7, 21. This set contains 4 elements 1, 3, 7 and 21, each of which divides 21. That is factor of 21. So this form is tabular form or a roster form. Tabular form of or roster form. Then we can take one more example, set of even natural numbers. We take set of even natural numbers 2, 4, 6. 3 dots indicate that same pattern continues. This is also a roster form. Of course, this will be infinite set. This will be infinite set because the counting does not stop. Infinite set. Then set of all prime numbers less than 15. Set of all prime numbers less than 15. Let us write them. 2, 3, 5, 7, 11, 13. And close them in curly braces. This is set, let us say M, will be the set in roster form or tabular form. So remember, in the roster form, elements will be written actually, and these will be separated by using commas, and the collection will be enclosed in curly braces. One thing you keep in mind, then we can discuss under the heading note, that order of listing element, order of writing element is immaterial. Order of writing element is immaterial. It has no relevance. Means for a set A, it has same meaning whether you write it 2, 3, 4 for some set, or it could be written as 4, 3, 2, 4, 3, 2, or even 4, 2 and 3. 4, 2 and 3. These three represent same set. These represent same set. So remember, the order of writing elements in a set does not matter. Does not matter. Second point, you please keep in mind that we should not repeat any element in roster presentation. We can write the word, let us say Naman. Naman. It contains A 2 times and N also 2 times. In set form, we write it as N A M. N A M. That's all. Here N is coming 2 times, we write it once only. A is also coming 2 times, we write it once only. M is already coming 1 time. So if any element is repeating in the given word while writing it in the roster form or tabular form, the elements will be written once only. Repetition is not allowed. We do not repeat elements in a set. Repetition has no meaning. Then we talk about set builder form. We talk about set builder form. The other name is property defining method. Property defining method. So in set builder form, what do? We write the general element of the set, say X, along with the property or properties it satisfies. Property or properties it satisfies. For example, if I say set of natural numbers less than 10, so set A will be X, element X, such that, it stands for such that X belongs to natural number and X is less than 10. So this element X, general element, has a two properties, that is it belongs to set of natural numbers and it is less than 10. So when we write the general element of this set with the property or properties, this form is called this form is called set builder form. Other name is property defining method. Property defining method. Similarly, we can take some more examples, like set A is given to us. Set A is given to us. Let us say 0, 1, 4, 9, 16. So here, how to write in set builder form? So see, just by common sense, this square of integer, such that x belongs to integers. X belongs to integers. And if I put comma and write 3 dots, it means it continues. 3 dots, 1, 2, 3, 1, 2, 3. So this will be set builder form. We write the general element with a property it satisfies. Property it satisfies. So here we can also write y is equal to z square, y is equal to x square. Other way, so little with a defined way, we can write y is equal to x square. X belongs to z. So the values of y will be written one by one. That will be giving us this original set. Now we take some problems to clarify the concept further. Set of all letters in the word teacher. Describe the following set in roster form. The question is, describe the following sets in roster form. Describe the following sets in roster form. The first is, the word is teacher. Teacher, teacher. The letters used are T, E, A, C, H, A, R. So here E is used two times. Let us write in tabular form or roster form. The set will be G, E, A, C, H, R. I have written E ones only. I have written E ones only. So this is tabular form or roster form. Second problem is the word is student. The word is student. The letters used here are S, T, U, D, E, and T. So T is used twice. T is used twice. With the same reasoning, in the roster form, we write it as S, T, U, D, E, N. So second time 2 I am not writing because a repetition of element in a set is not allowed. Student, S-T-U-D-E-N. So it contains only how many? 6 elements. It contains only 6 elements. Next word is intelligent. Intel, I-N-T-E-L-L-I-G-E-N-T. Intelligent. In the word intelligent, I is repeated. I is repeated. E is also repeated. T is also repeated. And L is also repeated. N is also repeated. So I leave it homework for you to write it in the tabular form. Tabular form. The set will contain only 7 elements. The set, once you write, will contain only 7 elements. I expect you to write it yourself. Write it yourself. Then set of all even numbers. Set of all even numbers less than 10. Set of all even numbers less than 10. 2, 4, 6, and 8. This becomes the set in roster form. One more example is set of all prime numbers less than 10. Set of all prime numbers less than 10. 2, 3, 5, and 7. 2, 3, 5, and 7. Then on second type, we take problem. Describe the following sets in set builder form. Now we are to write in set builder form. Set builder form. Write in set builder form. Like the set of all letters in the word function. Function. Tion, function. So in set builder form, we write this will be set A, having general element denoted by x, such that we can write such that this way or this way, such that x is the letter of the word function. X is letter of the word function. We can put in single commas just to differentiate. This becomes set builder form. Set builder form. See second example. Set of all the balls in the word geometry. 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 So we write it x such that x is ball, ball, used in word geometry. Geometry. Okay, if I ask you to write this set in tabular form, then what will be the elements? E being ball, O, E and O. I think there is none else. J, E and O. E is repeated, we write it once only, that's all. E and O. So this becomes tabular form. The previous one is set builder form. Set builder form. Then set of all even natural numbers. Set of all even natural numbers. Let us say this is set A x such that x is equal to 2n and n belongs to set of natural numbers. We want to write only even natural numbers. Even natural numbers means if I start with 1 into 2, the first element will be 2. Let's verify it. Put n is equal to 1. We get element as a 2. Put 2 here. 2 into 2, it is 4. Put 3 here, it is 6. Onwards. So these are all even natural numbers. It means the element of this set will be obtained by multiplying the respective natural number by 2. So this becomes set builder form. This becomes set builder form. Then set of all odd natural numbers. 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 See, it will be set A x such that x is equal to 2n minus 1. If I write plus 1 here, then the first element will become 3. We want to start with because the first natural number is 1, not 3. We want to include 1 also. And n belongs to capital N, set of natural numbers. It just by common sense that we make the prediction. See, put n is equal to 1. Let us verify it to be the true statement. N is equal to 1. 2 minus 1, 1. It becomes 1. Then put n is equal to 2. 2 to 4 minus 1, it is 3. And put 3. 3 to 6, 6 minus 1, 5. So these are all odd natural numbers. It means the general form of odd natural number is 2n minus 1. By putting value for n, we can get the corresponding natural number, which will be, of course, odd natural number. Odd natural number. Then we take next example. Set of square of all natural numbers. Set of squares of all natural numbers. It will look like set of squares 1, 4, 9 onwards. These are squares, set of squares. Now, the general format to represent these numbers will be, let us say, set A, x is a general element such that x will be n square and n belongs to natural numbers. Put n is equal to 1, 1 square is 1, first number. Put n is equal to 2, 2 square 4, second number. N is equal to 3, 3 square 9, third number. So the process continues. So this way we can calculate Similarly, the next one is the set of reciprocals of all natural numbers. Set of reciprocals of all natural numbers look like this: 1 by 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5 onwards. That way. So x is such that x is equal to 1 by n. As n varies, x will also vary. N belongs to n. N belongs to n. So this is the second type we have covered. X is equal to 1 by n. N belongs to set of natural numbers. So this becomes the general element. So this is also set builder form. Other name for it is property defining method. Now let us take up third type. Describe each of the following sets in roster form. We are given set in set builder form and we need to convert it into a roster form. First is x such that x is ball of the word mathematics. Mathematics. So here the vowels used are A, E and I. A, E and I. Of course, A is repeated, but we will not repeat. Repetition is not allowed. Therefore, the set will be It is denoted by A dash. It will be set containing elements A, E, and I. A, E, and I. These are three elements. A, E, and I. Then we take second example, x such that x is positive integer and divisor of 21. It is given x such that x is positive integer and x is divisor of 21. So let us write it by A. We want to write this set in set builder or roster form. So the positive integers which are divisor of 21, which are factors of 21 are 1, 3, 7 and 21 itself. 1, 3, 7 and 21 itself. So this becomes the set in. So we have converted into roster form. Roster form. We are changing only the form on the way we are representing. Ultimately, these are same sets. Then we take next example. It is given x such that x is equal to 2n and 1 less than equal to n less than equal to 20 and n belongs to set of natural numbers. Natural numbers 1 to 20. 1 to 20. So let us write these. Will you write? Okay, leave it homework for you. One sum I leave for you. This is homework. You can do it yourself. Okay, we'll do. See more examples. X such that x is equal to n square and n lies between 5 and 1, means 5 is included and 1 is not, and belongs to set of natural numbers. So let us write the elements. Actually n is greater than 1, so minimum number to put is 2 because n has to be natural number also. So 2 square, then 3 square, then 4 square, then 5 square. This becomes set. If you wish, you can write their values also. 2 square 4, 3 square 9, 4 square 16, 5 square 25. 5 square 25. Then we can take part 5. Part 5, x such that x is equal to 1 by n and it is given that 1 is less than equal to n, it is less than 5, n belongs to set of natural numbers. So n is at most 4. Let us put values. N is 1, it is 1 by 1, and 2, 1 by 2, and 3, 1 by 3, and 4, 1 by 4. That's all. That's all. So here it is given that n is not equal to 5. We stop here only. So this becomes set builder in roster form. This becomes set in roster form or tabular form. It was set builder form. It was set builder form. It is roster form or tabular form. A tabular form. Then sixth part also we take. Sixth part, it is x such that x is equal to n minus 1, and we are given n less than equal to 5 and greater than equal to 1, and n belongs to set of natural numbers. Let's put values. N is a minimum 1. 1 minus 1, it is 0. X becomes 0. And put 2. 2 minus 1, 1. 3, 2. 4, 3. 5 is also included. 5 minus 1, it is 4. So this becomes set builder form. This becomes set builder form. Then the next type is conversion from roster form to set builder form. Conversion from roster form to set builder form. See, first is set A. It is 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5. I can write it 1 as 1 by 1 also, just for convenience. Now, this set, when it in the set builder form, you see these 1, 2, 3, 4, 5 are natural numbers. We have taken reciprocals of natural numbers. It means we can write x such that x is nothing but reciprocal of natural number, and the value of n goes up to 5 starting from 1. It means n is at most 5 and minimum 1, and of course n is natural number. The basic idea is we have to give the complete meaning of x. What x is? I have told you it is the reciprocal of natural number, and n will be at most 5, and n will also be, n will be of course natural number. I have told you. So this form becomes this form becomes, what do we call it? Set builder form. Second is, say 1, 1 by 4, 1 by 9, 1 by 16, 1 by 25. We can write this one as 1 by 1, just for understanding. 1 by 4, 1 by 9, 1 by 16, 1 by 25. Now you see here the bottom numbers are simply squares of natural numbers. 1 square, 2 square, 3 square, 4 square, 5 square. They are squares of natural numbers. And the maximum value taken by n is 5. 5. And of course, these are natural numbers. Using these conditions, let us write it is x general element such that x is equal to reciprocal of square of natural number, and n is at most 5 and minimum 1, and n of course belongs to natural numbers. So here there is one correction. These dots are put in the statement, but let us exclude these. Move these dots. I will use only for finite set. Finite set. I've stopped here. No dots, please. 1 by 4 up to 1 by 25. This will be the set. In case dots are there, and in the case we can write for that also. In case dots are there, then it will be x such that x is 1 by n square, and n belongs to set of natural numbers. Then we will not be putting this condition. This condition is restricting us to move up to n is equal to 5 only. In the book, dots are given, but I took this statement without dots. For this statement, this is correct. In case dots are there, then we have to take up this result. So with the dots, this result; without dots, this result. Both are set builder form. Both are set builder form. Both are set builder form. Then you see we take C as 0, 3, 6, 9, 12. Dots are there. Same pattern continues. So these are a multiple of integers. 3 times. Say x such that x is equal to 3 times n. It contains 0 also. So which integers? Non-negative integers, which we call whole number also. Integers, non-negative integers. So n is non-negative integer. Non-negative integer means whole numbers. Non-negative integer means whole numbers starting from 0, 0, 1, 2, 3, 4, 5. We can verify n is equal to 0, x is 0, n is equal to 1, it is 3, n is equal to 2, 3 to 6, 3, 3, 9, 4, 3, 12 onwards. So this becomes property defining method. This becomes property defining method. Property defining method. Then See part 4. Part 4. D. It is 4, 5, 6, 7, 8, 9. 4, 5, 6, 7, 8, 9. These are simply natural numbers. More than 3, less than 10. So it is x such that x is simply a natural number, and here n is at most 9 and at least 4. Of course, n belongs to natural numbers. So this becomes again set builder form. Set builder form. This becomes set builder form. See, next part, it is f. It is 1, 4, 9, 16 up to 100. If you see carefully, these are squares of natural numbers from 1 to 10. From 1 to 10. So this we write as x such that x is equal to n square, and n is at most 10. Of course, minimum it is 1 here, and we write n belongs to set of natural numbers. So this becomes set builder form. Hope you understood. Set builder form. Then part 7, you see set G. It is 5, 10, 15, 20, 25, so here also these are multiple of 5. And of course positive multiples. So we write it as x such that x is equal to 5n. N belongs to natural numbers. We can verify n is equal to 1, 5, and 2, 10, and 3, 15, and 4, 20 onwards. Last part here is it is 5, 25, 125, 625. So square 5, 5 square, 5 cube, 5 raised to power 4. Very easy. It is x being general element such that x is 5 raised to power n, and here n can take maximum value 4 and minimum 1. N belongs to natural numbers. We'll take more problems in the upcoming video. Thank you for being with me.